Functions provide serverless compute for Azure. It allows us to focus on code that matters the most to us, and Functions handles the rest. Azure Functions allows us to build web APIs, respond to database changes, process streams, handle message queues, etc. With Azure Functions, we write less code, have less infrastructure to maintain, and in turn, we save on the cost. In this video, let's write our first Azure function to process messages coming into a queue and learn more about how Azure Functions work and how to set this up. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. I'm sure one of this interests you, so make sure to hit that subscribe button and help me grow this channel. Without much delay, let's head off right into Visual Studio and create our first Azure function. Here, I have an existing project that I had used for my previous video when I talked about Queue Storage. Now, if you're new to Azure Queue Storage, I highly recommend checking out that video, which will be linked here and in the description below. To give a quick recap on this project, this is an ASP.NET application which has the startup, program.cs, and the default weather controller. I had added a new endpoint in this, which was the post method, which was to send messages to a Azure storage queue. Now all this does is take in a weather forecast object, serialize it, and send it using the queue client. The queue client in this case was injected in using the constructor and was wired up in the startup.cs using dependency injection. So I showed how to use managed identity to connect to queue client, which removes any need for username and password in this particular connection to the queue client. I had also created a weather data service, which is a background service job that runs every 10 seconds to poll the queue for messages. Now, as and when we post messages into the queue, this service polls and reads the message and processes it. In this particular example, all we did was just log out that particular message to simulate that it is processing the message. This background service is also registered in the startup.cs. If we want more control on the processing of these messages, scale on demand, etc., then using a background service might not be the best option. A more appropriate option would be to use an Azure function which can run independently on a same service plan or even different and scale separately as well. So let's move this background service to an Azure function and learn more about Azure Functions. So first, let's comment out this background service so that this doesn't get run on application startup. To create a new Azure function, let's go on to the Solution Explorer, right-click and say Add New Project. In here, if you have installed the right templates for Azure, you should be able to see an Azure function option. To do that, you can search or even filter it using the drop-down boxes here. I have this already filtered down, so I have Azure Functions in the list here. So let's click this and click Next. Let's give this function app a name. So let's call this Weather Data Ingester because it ingests in weather data objects. So let's leave the location as the same and click Create. This prompts a further dialog which enables you to select the different templates for building Azure Functions. You can see there are different options inside here, starting from empty, where you can build from a blank project. There are also different triggers based on which you can create these Azure Functions. Triggers are what causes an Azure function to run. A trigger defines how a function is invoked, and a function must have exactly one trigger. So this is basically the triggering point for the function. Now, this could be an API endpoint, in which case a HTTP method would be the trigger for the Azure function. You could also trigger based on various other options. This is exactly what we are getting to choose in this particular template here. So as you can see, you can do a service bus queue trigger or an HTTP trigger, which is basically for the API based. And you can also have a timer based trigger, queue, blob, etc. Now in our example, we were dropping the messages into an Azure Queue Storage. So choosing the queue trigger is the most appropriate for us. So this gets triggered every time a message gets dropped into our queue, which is exactly what we want. So let's select that. Make sure you're using the appropriate .NET version. In this particular case, I will use .NET Core 3. On the right side, we have the option to select a storage account. An Azure function, when it runs, needs to have a storage account. This storage account stores the metadata that's related to the function and its running. In this particular case, I can choose storage emulator when I am running on my local machine. So let's leave it like that. This also asks in for a connection string setting name, which is basically the app settings name that you will be using for the connection string. This is the connection string to the queue that we will be listening for this queue trigger. So let's name this weather data queue because that is where we are going to have the messages come in. Now, if you remember from the previous video, I had used the queue name as add weather data. Now I'll show this again in the source code, but let's leave it like that for now and click create. This will create a new Azure Function project which is triggered whenever a message drops into a queue. So we have the weather data ingester project successfully created, and this has the function1.cs file. It also has the host.json and a local settings.json, which we will soon see what it stands for. Even though we gave a name for the function name is still called as function1. So let's rename this to be more appropriate. So let's name this as process weather data because this function is actually going to process weather data messages. Now, if you see here, this function has an attribute which is the queue trigger and has the queue name and also the connection string name that we had specified. This means that anytime a message is dropped in this particular queue on this particular connection string name, then this particular function would be invoked. This is exactly what this queue trigger handles for us. Here we have a static run method which takes in two parameters. Now, if you look at the methods that are recognized as functions, the function name attribute is what marks as the function's entry point. Now note that the name must be unique with the project and should start with a letter. And there are certain constraints on the type of attributes that it can contain. The method signature parameters needs to have one trigger attribute, which is what we have with the queue trigger, and it can have a few other parameters. Now, if you look at here, the options that you have are basically the logger or the trace writer, a cancellation token, and binding expressions parameters. Also note that the order of parameters in the function signature doesn't matter. So basically, you can switch around the parameter order in the function that we just saw. If we come back to our method, here we have one trigger, which is the queue trigger, and we also have the iLogger being injected in. So this is automatically being injected by the runtime when this function gets invoked. This function, by default, just logs the queue message that it receives. So we receive the message as a string, which is basically the body of that particular message. Now when we use the queue trigger attribute, it expects the message to be base 64 encoded string. You can update the options so that this is also changed. But in this particular case, let's make sure that the messages that we drop to the queue are base 64 encoded. So if we go back into our startup.cs where our queue client is registered, we can see this takes in a queue client options. This is where we can update that it needs to be a base 64 encoded. So if you look at the parameters here, there is a queue client options being passed in. So let's name this as options and then update the options to have base 64 encoding. So let's set the options dot message encoding and set this to be base 64. So let's say queue message encoding dot base 64. Now to pass in these options, we have the queue client here. So after we pass the credential, we can also pass in the options to it. Now this is going to make all the messages that this queue client is going to send as base 64 encoded. Let's switch back to our function1.cs and look at the connection string here. So this uses the weather data queue, which is the connection string name for this particular queue trigger. So if we go into the solution explorer, under the local settings.json, which is like a local configuration file, we can add in a value for those connection string. So let's switch back, make sure to copy this and come back to local settings.json and add in the connection string for this. So let's add the weather data queue and also pass in the connection string for this particular weather data queue. To get the connection string, let's switch over to the Azure portal and go to our weather data queue. So under the access keys in the storage account, you can get a connection string to this particular queue. So let's say show keys and copy this connection string. Note in the previous video, I had shown how to use managed identity to connect to the queue when sending messages from ASP.NET. We'll get started with the connection string, and I'll also show you how to use managed identity with queue trigger as well. So let's copy this connection string, come back to our Visual Studio and paste this as the weather data queue connection string. Now when this function is going to run, it's going to look at this connection string name, get the connection string, and use that to connect to this particular queue in that. Let's run this project and see this in action. So let's make sure to put a breakpoint here and run this application. So let's right click and say set startup projects and set both the projects to be running. So let's say multiple startup projects, and let's give the action as start for both of them and click apply. Now if I click F5, both of these projects are going to be run. Now one of them is our web API, which will launch the Swagger API endpoint, and the other one is going to run the function on my local environment. Now I have the Azure Functions core tools installed, which is also part of the Visual Studio installation. You can also get it as standalone, so if you haven't installed it, make sure to install that on your local machine. You can see that this is starting the Azure Storage emulator, as we had selected the storage emulator for the default Azure's storage needs. Now this is also set up in the local settings.json, where you can see Azure Web Job Storage is set to local development storage. This again is the storage to manage the metadata of the function that is running. This has nothing to do with the actual queue that we are listening for messages. Now the Azure function is running successfully and it's waiting for a message to appear. Let's switch back to our Swagger endpoint and post a message to our endpoint. Say try it out and may give the message as first function message. And click execute. Now this is going to use managed identity, connect to the queue, and drop a message as base64 encoded version. The message was successfully dropped and immediately it got picked up by our function and we have hit the breakpoint here. This is because this queue trigger is listening on the same queue that this message was dropped in. Now if we look at the message queue item, we can see the string message that we just passed. So you can see the first function message in the summary here. So let's click close and continue execution of this particular function. This logs to the logger as expected. So here in the console, we have this log statement which says queue trigger function processed. Now if we remove the breakpoint and drop in a lot more messages, we can see all of these messages getting processed. So let's click execute a couple of times and you can see as and when these messages are arriving, the function is automatically picking this up. So we have successfully added a new Azure function to process the messages that's coming into the queue. If we switch back to our queue, go to the queues and select the add weather data, we can see that the messages have also been removed from here, which means this was successfully processed. Earlier, when we did the weather data service, we had to explicitly delete the message to indicate that we had processed the message. In this particular case, the queue trigger is doing this automatically for us. But it marks this as deleted only if the function returns a success. In any case, if we throw an exception, then that message will not be processed. So let's say if we had a condition here, if my queue item dot contains, so let's say we are going to pass in a message which contains exception. So let's name this as exception. Then we can throw a new exception inside this particular method. This is just to simulate an exceptional case for certain types of messages. So let's say new exception and say exception found in message. So in this case, this function will not be successfully completing anytime a message has the word exception inside this. Let's run this and see this in action. We have both the Azure function and the web API running. So let's again go to post, try it out and drop in a message. Now this message does not have exception inside it, so this is going to be processed successfully. You can see the message was picked up and it was processed. It marks the message as successful. So if we switch over to the queue and refresh this, you will not be able to see the message here, because the queue trigger knows that we have successfully processed the message because there was no exceptions inside the handler. So let's come back to the API and drop a message with an exception. So let's say message with exception and click execute. Now this is going to drop a message that is going to throw an exception inside the function handler. So let's continue the execution here. As soon as we continued the execution, the message got picked up again. So this is again throwing the new exception here because this message was reprocessed. Now if I continue this again, this is going to keep going for a couple of times. Now if we go back to the console where the Azure function was running, you can see here this exception message was logged 5 times. This is because we have a default setting of maximum DQ count on the message to be 5. So every time we DQ the message, the DQ count on the message increases. Once it has reached 5, it will move this message to add weather data -poison. This is just by convention that it appends the -poison, which is similar like a dead letter queue, where the messages that could not be processed are being dropped in. Since we don't have this queue created, this message will not be there as well. So let's come back to this particular queue that we have and create a new queue and say add weather data -poison and click OK. Let's come back to Visual Studio and make sure to run the application. This time I'm running it without debugging using Ctrl and F5, which starts the both projects without debugging. So let's click weather forecast, try it out and say again message with exception and click execute. Now this is going to drop the message into the queue, which will be picked up by our Azure function that is running locally. The message was successfully posted. You can see the function has already picked it up and this has run exactly 5 times and it has again errored out this maximum limit. Finally, it moves the message to the add weather data -poison queue. If we come back to our queues, if we go to the add weather data -poison queue, you can see this message will now be available here. Now, you can use this to manually monitor the messages and see what has gone wrong and reprocess these messages if required. In a real-world application, it could be because of some mishandled scenarios or some invalid data in your messages. Based on this, you will have to do appropriate processing. If you want to modify any of these default settings, the DQ count, etc., you can do that by using the host.json file and giving in a settings file. So here we have the extensions, queues, and the default settings being applied here. You can override this if this is something you want. Let's copy this, come back to our source code. In the host.json, let's paste this in. So after the version, let's paste in the extension and the queues property. Let's simply specify the maximum DQ count because that's the only thing we are currently interested in. So let's remove all the other settings and make this as 2. So we are specifying explicitly that the maximum DQ count must be 2. Let's run this application again and see what happens. Both the applications are running. Let's click try it out and specify the summary as new exception and click execute. This has successfully dropped the message to the queue and our Azure function has picked it up as expected. You can see this time it has only picked up the message 2 times and we have a message here that maximum DQ count of 2 has reached and this will be moved to the poison queue. This is because we had explicitly set up the maximum DQ count to be 2 inside our host.json file. So if we go back to our queue here and refresh the poison message, we can see the new message as well inside here, which is the new exception. Now that we understand how Azure functions work, let's see how we can use managed identity to connect to these Azure queues. Inside function1.cs, we had specified a connection string, which is now specified in local settings.json file. Now this is used while you're running locally. When you have deployed this function to your Azure functions, you will have to specify this as part of your application settings or environment variables in the function environment. But let's see how we can completely avoid the need of this connection string. To use identity-based connections, which includes managed identity, you will need specific versions of the Azure Queue NuGet packages that's being used. For Azure Queues, we need 5.0.0-beta 1 or later. Once you have the latest NuGet package, you can use specific conventions to give in the queue name that it has to connect to. So in this particular example, we'll have to specify a service URI in the end for the connection string name. Let's see how this works in action. So if we come back to our function, go to the NuGet packages. Inside here, you can see that we use the Microsoft Azure Web Jobs extensions.storage and the version is 3.0.10. Let's update this first to the latest version. So let's right click and say manage NuGet packages. Let's select update and make sure to include pre-releases because as you can see, it was a beta version that we were looking at. So let's select the extensions.storage and select the latest versions. In this case, this is beta.5, which is greater than beta.1. So let's click update, which will update this NuGet package. Let's click accept, and this has installed the latest package into our Azure function. Let's collapse this, come back to our local settings.json and remove this particular connection string. Now, this Azure function, which has the queue trigger, is coming from the latest NuGet package. This still needs to know which is the URL that it has to connect to for this particular queue. So we will still leave in the connection name as weather data queue, but in the local settings.json, we will specify that this is a service URI. To do that, let's give double underscore and specify service URI. This is exactly what was specified in this documentation here. So let's make sure we have the appropriate case. So the U and R and I is not capital. So let's leave it like that. Let's navigate back to our Azure queues. So let's go to the storage account, go to the YouTube demo. Under queues, let's copy the full URL to this particular queue. So let's copy that, come back and use that as the service URI. The Azure function should now be using default Azure credential to automatically connect to this particular queue. Now earlier in the Queue Storage video, when we registered the queue client inside the startup.cs, we had explicitly used default Azure credential and set up the managed identity for my user in Azure for the storage queue, because of which this is automatically able to connect to this queue. Since this function is also running under the same context, it will also be able to connect automatically. So to recap, if I go into the storage queue, if I go under access control IAM, you can see role assignments, and this is where we have given the users that can connect to this queue. So here we had specified my user does have access to the storage queue data contributor. Now you can see two IDs because one is the domain specific ID and also the other one is the external user, which is my Hotmail ID, under which my Visual Studio is running. Now the storage queue data contributor role allows us to read, write and edit messages inside this queue. Before we run the application, under the local settings.json, let's make sure this queue name is removed from the service URI. All it needs is the URL to this particular storage account, which has the queue and core windows.net inside it. Because the queue name is being specified inside the add weather data as part of the queue trigger. Let's run both the applications and see this in action. Both the applications are successfully running, and you can see this has already picked up a message from the queue. So let's drop one more message. So let's say post, click try it out and drop this message as is. Because this doesn't have any exception, this should get processed successfully. This message was successfully posted, and you can see inside the Azure function, it was also picked up and processed as expected. Now, as you can see, we don't have any connection string inside the local settings.json file, and this is all connected using managed identity. Let's now see how we can deploy this Azure function to the Azure infrastructure. So let's go to the Solution Explorer, right-click our Azure function and select the Publish option. Now this is directly publishing the function from Visual Studio. If you want to set up a build deploy pipeline, I have a separate video that walks through the entire process. The video will be linked here or in the description below. In the Publish dialog, let's select Azure and select Next. Since this is an Azure function, let's choose Azure Function App Windows and click Next. Since we don't have an existing function app, let's create a new one inside our resource group. So let's click the plus button and create a new function app. So this allows us to specify the name. So let's remove the date. Let's select the appropriate subscription and also the resource group. In this case, I'll choose delete. Let's keep the plan as consumption. You have other plans as well. We'll do a separate video on the plans and scaling later in this channel. For now, let's leave this as consumption plan. Let's move the location to Australia and select Australia East. Now we need to select a storage account for this Azure function. While we were running locally, we used the storage emulator. But once we publish to the Azure function, we need to explicitly specify a storage. So let's create a new storage for this particular function as well. So let's specify all the defaults. Let's make sure to select the location to Australia and select OK. Clicking create is going to create this Azure function app in the Azure infrastructure. So you can see the status on the dialog here as well. So right now it is creating an app service. If we switch back into our Azure portal, go to the overview and go into our resource group, which is delete. So let's click delete from here. That's going to show all the resources in that particular resource group. Once this is successfully created, we will see the Azure function in here. The function is successfully created. So if we switch back to the Azure portal and refresh here, we can see the Azure function and the associated storage account being created here. So let's click next to generate the publish file. You can also generate a CI/CD using GitHub Actions workflow right from here, which will generate a YML file. But for now, let's keep it simple and select the publish option and click finish. So this will create a publish profile for our application within Visual Studio connected to the function that we just created. Once we click publish, it's going to deploy this function into this Azure function that we have created. So let's click publish, which will start the deployment process. Now in a real world application, I would be using a build deploy pipeline to deploy these Azure functions so that anytime you push the code into your source control, it will automatically deploy into these Azure functions. If you want to do that, check out my other video that was linked earlier. The publish was successful, so let's switch back to Azure portal and go into the weather data ingester function that we have created. Inside this, if we navigate to functions, we will see the function which is the process weather data. This has the trigger from queue and it is all ready to be run. Now before we run this, we need to make sure we enable managed identity for this Azure function. To do that, on the left side of the function, let's scroll down and select identity. You can see this is turned on by default. So let's now assign the storage queue access to this function as well. So let's navigate back to our resource group, go into the storage queue, which is the YouTube video demo, and go to IAM again. Here we can click add and specify add role assignment. Let's select the same role, which is the storage queue data contributor, and search for our function. So this should be named weather data ingester. So you can see this is a function app. So let's select that and click save. Now here we have assigned the identity of the Azure function and access into this particular storage account. So you can see this has storage queue data contributor and we have the weather data ingester as well. This is an app service or a function app. With this access set up, the Azure function should now be able to run successfully. So let's go back into delete, go to the Azure functions. Under configuration, let's make sure to specify the configuration value for this storage account. Let's click new application setting from our local settings.json file where we had specified the queue connection name. So let's go into that and copy this particular value. So let's say weather data queue underscore service URI, go back and use that name and specify the queue URL as well. So let's copy this and paste this inside the app settings. So let's click OK and click save to save this particular settings. This is going to restart our application. So let's say continue. So the settings is all successfully updated. Let's go to the functions and in the process weather data, let's make sure this is running successfully. So let's go into code and test where we can see the details of this function.json and you can also expand the logs down below here. So let's expand this, which says successfully connected. To drop a message into the queue, let's run our web application. So let's come to the Solution Explorer, right click from here and run this application. So let's say debug and start a new instance. Now I don't have the Azure function running on my local machine because of which it will not pick up the messages from the queue. The Azure function will pick this up. Normally, you would have this web app also in the same environment that you are testing this. But for this demo, I have just chosen to keep the web application in my local environment. I could use the same publish mechanism to publish this app into Azure infrastructure. So let's go to Post, select Try It Out, and drop the message inside the queue. The first time it drops the message, it takes a while to connect because it's trying to set up the default Azure credential and validate the whole connection. Once that is in place, this token would be cached and the subsequent request will be faster. The message was successfully dropped. Let's click execute a couple of times, which will drop a few more messages. Let's navigate back to the queue, and here you can see inside our Azure functions, all those messages were successfully picked up. If you were to drop a message with exception in it, the Azure function would also throw an exception. To test that, let's come back to our web application. Let's say message with exception and click execute. Now this is dropped successfully, and you can see in the Azure function, we see these error messages. This has again picked it up 2 times because we had the override for the maximum DQ count to be 2. I hope this helps you to get started with Azure Functions, how to set this up, and how to wire this to queue messages. Now, using an Azure function, you can scale this separately to your web app and also to your background services. So in cases where you want to scale the processing of the messages, so let's say you expect a load of messages to come in at some time, you can set up appropriate scaling for your Azure functions. I will cover how to do that in a separate video. If you like this video, please make sure to hit the like button. If you have any comments, questions, or feedback, make sure to drop a message below. If you want to be notified of similar such videos in the future, don't forget to hit subscribe. This also helps me to grow this YouTube channel. Thank you and see you soon.